group Eliza Arabis, Conag Rico J, Diaz Vanessa. And our topic for today is all about magnetism, and these are the subtopics. We have the magnetism, magnet, law of magnetism, magnetic substances, magnetic field, and magnetic induction. So good morning once again. I am Eliza Arabis. I'm going to report about the magnetism and law of magnetism. Magnetism, in terms of application, magnetism is one of the most important field of physics. Large electromagnets are used to pick up heavy loads, magnetic tapes, and these are used routinely in sound and video recording equipment and to store computer data. So kanang commonly nga mga gamit sa ato ang balay kay naa na siya mga magnets, just like sa kani atong laptop naa ni siya magnet. And sa una ganahan kami aning mangguba og kanang mga DVD ba or kanang mga guba nga DVD among kuhaan og magnets. Intense magnetic field are used in magnetic resonance imaging or MRI device to explore human body with better resolution and greater safety than X-ray can provide. So kani kabaw sa MRI. So kaning MRI, it is used sa mga hospital, and mura ni siya kanang X-ray nga mo check sa atong mga inner parts sa kalawasan. So like X-ray, ang difference lang kay ang X-ray mga kuan man, mga bukog o mga na-dislocate nga bukog. Whereas sa MRI, kay it is more versatile and doctor use it for many medical conditions. So MRI are better evaluating such as soft tissues, brain tumors, spinal cord injuries, and so on. So this is what an MRI looks like. Kakita na mo ani. So kaning sa ikaduha nga peak, giant superconducting magnets are used in cyclotrons. So mao ni siya cyclotron that guide particles into target at nearly the speed light. So cyclotrons used to treat cancer. So ion beams from cyclotrons can be used as proton therapy to penetrate the body and kill the tumors by radio damage. So inside ani kay naay mga magnets. Next is railguns. So railguns use magnetic forces to fire high-speed projectiles and magnetic bottles called antimatter, a possible key of future space propulsion system. So mo ni siya ang railgun. So commonly makita ni nato siya sa kanang mga battleships kanang mayon ana ba. So next, magnetism is closely linked with electricity. Magnetic field affect moving charges, and moving charges produce magnetic field. So later on we will discuss about magnetic field or what magnetic field is. Changing magnetic field can even create electric field. These phenomena signify an underlying unity of electricity and magnetism, which James Clerk Maxwell first described in the 19th century. The ultimate source of any magnetic field is electric current. Next, we have the magnets. A magnet is a material object that produces magnetic field. This magnetic field is invisible but is responsible for the most notable property of a magnet, a force that pulls on ferromagnetic materials such as iron and attract or repel other magnets. So, kailan naman taon sa kanang mga magnets sa? So, next. So, this one, kani inyong mga nakita nga picture So as we all know, mao ni siya murag indication or like sample sa kanang magnet. We assume that magnets has the shape of a bar. So mao ni siya shape of a bar. Iron objects are most strongly attracted to either end of such bar magnets called its poles. So this one here, oops. This one here are the poles. This one, the North Pole and the South Pole. One end is called the North Pole, as I said, and the other is the South Pole. Magnetic poles also exert attractive or repulsive forces on each other, similar to the electric forces between charged objects. In fact, simple experiment with two-bar magnets shows that like poles repel and unlike poles attract. So we will talk about that later. The extent to which a piece of material retains its magnetism depends on whether it is classified as magnetically hard or soft. So soft magnetic materials such as iron are easily magnetized but tend to lose their magnetization easily. So kanang mga magnetic materials such as iron kay dali ra daw siya mo pilit but dali mo let go. Ouch. These materials are used in course of transformers. So kanang transformers ka kuan na mo say transformers kanang naa sa mga sana kanang katong kanang mga naa sa poste ba, mga transformers and then generators katong mga gipanggamit pag bagyo kay way kuryente and motors. Iron is most common choice because it's inexpensive. Next one, we have the hard next classification of magnetism is hard magnetic materials. So hard magnetic materials are used in permanent magnets. Such magnets provide magnetic field without the use of electricity. Permanent magnets are used in many devices including sa mga loudspeakers, permanent magnet motors, and the read-write hand of computer hard drive. So kato atong mga atong hard drive, mga speakers na ana siya mga nakatouch ng mga magnets. Next is the law of magnetism. Tana sa tag video. Oops. Why so loud? Makita ra?
Yes po.
Laws of magnetism. Let us perform an experiment before stating the laws of magnetism. Suspend a bar magnet as shown here. Allow it to come to rest. We observe that the magnet aligns itself in the north-south direction. Bring the south pole of another magnet near the south pole of the freely suspended magnet. We observe that the south pole of the suspended magnet moves away from the south pole of the second magnet. Now bring the north pole of the other magnet near the north pole of the freely suspended magnet. We observe that the north pole of the suspended magnet moves away from the north pole of the second magnet. Thus we conclude that the like poles repel each other. Let us now see what happens if unlike poles are brought close to each other. Bring the north pole of the second magnet near the south pole of the suspended magnet. We observe that the poles attract each other. Now bring the south pole of the second magnet near the north pole of the suspended magnet. We observe that the poles attract each other. This shows that unlike poles attract. That is, we can summarize the laws of magnetism as like poles repel each other and unlike poles attract each other.
So, law of magnetism. So, katong sa gipakita nga video, it looks like this. Ang usa ka magnet kay gihiktan siya. And then, gipaduol ang kani unlike poles. Two bars can illustrate this. One is hang, this one, so that it swings freely. A pole of the second is brought in turn near of the two ends of the hanging magnets. One of the hanging magnet is attracted. A basic law of magnetism is that unlike poles attract each other. So as we can see here, this one is the South Pole and here is the North Pole. So ilang gipaduol silang duha. So what will happen? Mukuan ni siya, mupilit ni silang duha because kay according sa law of magnetism, unlike poles attract. Yeah, attract. And then if a North Pole here and then atong ikuan sa North Pole sad sa other magnet, what will happen? Mo-repel ni sila or dili ni sila mag-abot. Because like poles repel. So mo na siya ang pinaka-basic law of magnetism. Like poles repel, unlike poles attract. Okay? So the next reporter will be Rico.
Okay na audio?
Yes, Rico. Wait for a while, Rico.
So, good morning everyone. My name is Rico J.B. Conrad, and I am here to discuss about the magnetic substance. So magnetic substance magnetic substance are substance that get attracted. Ay lang na, usab Eliza. Okay. So again, the magnetic substance. So magnetic substance are substances that get attracted to magnets. So few of the magnet substances are iron, steel, and combat and nickel. So we know that there are different types of magnetic substance. So iron, steel, combat ang mo-attract or mo-attach ato sa magnet. So, daghang puglaing mga materials, pwede na to makuan siya na siya kanang magnetize or mo-attach siya sa magnet. So, ang kanin siya ng mga substance is if you bring a piece of iron closer to a magnet, so it get attached towards a magnet. So, kanin sila is kanang dili lang kay kanira ang mga substance na mo-attract. So most of the materials are can be magnetized. So In fact, most of the materials can magnetize and materials are magnetic or can be magnetized. So, according to an English physicist, si Michael Faraday, ang iyang gikuan, he classified the magnetic substances into three classes. So, that is next, Eliza. So, yeah, so si Michael Faraday ang um, classified sa tulo ka buok. According sa ila ang magnetic properties kung sa kaila-ilahi man sila unsa nag-attract sa magnet. So naatay diamagnetic substances niya, ferromagnetic substances and paramagnetic substances. So let's first know the diamagnetic substances. So Eliza, next please. The next, Eliza. Okay, so the first type of magnetic substances is the diamagnetic substances. So is one whose atoms have a no permanent magnetic dipole moment when an external magnetic field is applied to dynamic substance such as bismuth or silver. A weak magnetic dipole moment is in, induced in the direction opposite that applied field. So, ang kaning diamagnetic substances, kay yung mga example ani sige next is um, bismuth, lead, mercury, copper, diamond, gold, silver, o silicon. So, kani sila materials are kanang sana weakly magnetized in the opposite direction by magnetic field. So, ang kanin sila mo attract siya sa di siya mo attract sa magnet like mulikay siya. So, kanin na example next sa Eliza. So sa makita ninyo dito sa picture is gibitay ang kaning lead rod no niya. So lead rod is suspended in a magnetic field. It slowly sets itself right triangle to the direction of the field. The behavior of the substance is dependent of temperature. So ang kanin siya kanang ang iyaang kuan pag ato sa magnet siya ato sa gibitay na lead kay mo likay siya atong kuan in the opposite direction kung asa to ang magnet then sana katong giingon na right triangle kay katong sana for example sa kani nga siya ja kuan ato sa magnet kay mo kuan iyang katong lead mo ana siya into a right triangle. So kana sana dili siya mo sunod kung asa ang magnetic field kung asa ang katungkuan. So dili siya mo-attract siya. It's weakly magnetized. So gamay ra iya ang kuan dili siya mo magnetize sa magnet. Yeah. So the next so nakasabot ra mo sa diamagnetic substance. Dili siya mo dikit sa mo ni siya mga materials like katong dimension ako diamond, gold, silver, dili siya mo attract og magnet. So the next type of magnet substances is paramagnetic. So paramagnetic these are materials that are weakly attract to magnets. Paramagnetics are those substances which are attracted by a strong magnetic field. So ma-attract lang sila if kusog ang magnetic field. So, for example, so next, Eliza. Okay, so ang example ani ng mga substances sa paramagnetic materials is ang aluminum, platinum, chromium, magnesium, tungsten, and calcium. So those materials are weakly attached to magnet, but if the magnetic field is strong, nga to pala siya mo attach. So for example, next Eliza, kaning aluminum kay sana if masuspend siya sa magnetic field, it slowly aligned itself along the direction of the magnetic field. Aluminum is an example of paramagnetic substance. So unlike sa diamagnetic substance kay dili gid siya mo dikit. Same sila weakly magnetized, but ang kaning paramagnetic if strong ang katong yung magnetic field is slowly mo sana mo align siya ato kung asa ang direction sa magnet. So for the last types of magnetic substance is ferromagnetic substance. So ferromagnetic substance are materials which exhibit a spontaneous net magnetization at the atomic level, even in the absence of external magnetic field. So kani siya is kanang strong iyang magnetic properties. So dali ra siya mo attract or mo attach ato sa magnet na gamiton na if iduol lang nimo siya kay muduol po dayon siya dili pareha unlike sa paramagnetic na hinay siya mo kuan kinahanglan pa siya og kusog or mas duol para mo attract para mo dikito ang kato ng mga materials. So examples of this are kaning iron, ganiha, cobalt, nickel, steel, o alikono. So, kaning silang mga materials is paspas sila mo magnetize or mo attract sa kuan. So, for example, next Eliza. So, ang iron. So, if iron suspended in magnetic field, it quickly aligned along the direction of the magnetic field. So, kani siya is strongly magnetized in the same direction by magnetic field. So, when placed a magnetic field and is strongly magnetized in the direction of magnetizing field, temperature has an adverse effect on ferromagnetic substance. So, on a ferromagnetic substance, due to a rise in temperature, a ferromagnetic tends to lose its magnetism. So, any clarification or question about the three? So, I will summarize the three. So, ang diamagnetic is weakly magnetized in opposite direction. Yeah, ang paramagnetic is ang katong weakly magnetized, but if strong ang katong magnetic field mo attract siya or mo attach siya in the same direction. Yeah, ang kaning ferromagnetic is mo ni sila ang paspas mo attract strongly magnetized in the same direction of magnetic field. So for the next presenter is Eliza Arabis. Eliza Diaz will be reported about the magnetic field.
Vanessa Rico.
Sorry, Vanessa.
Hello, madungog ko.
Yes, Van.
Okay, thank you. So, good morning everyone. My name is Vanessa Diaz and I will discuss the magnetic field. So, what is magnetic field? So, let kanang tanawon sa natong video diri para makasabot sa unsa ng magnetic field. Please go Eliza sa video. Thank you. Mulai timong balay Jack.
Oh yeah, wait.
Field.
You are late again. Hurry up. Something is wrong.
The region surrounding a magnet in which the force of the magnet can be experienced is called its magnetic field.
Seems like a nice spot to relax. It's an alien ship. We must be careful. Run!
Take a bar magnet and keep it on a table.
Wow, such a colorful spacecraft. Let's go there. Activate transparent sheet.
Keep a transparent sheet on top of the magnet. Now take some iron filings. And sprinkle them on the paper.
Arrange yourselves.
The iron filings will start arranging in a definite pattern around the magnet. This pattern is called a magnetic field. The lines along which the iron filings arrange are called magnetic field lines. The magnetic field lines show the direction and strength of the magnetic field. Magnetic field lines always start from the north pole of the magnet and end at the south pole. Inside the magnet, their direction is from the south pole to the north pole. Thus, the field lines form closed loops. Field lines never cross or intersect each other. The closeness of the magnetic field lines tells us about the strength of the magnetic field in that area. The more closely packed lines indicate a stronger magnetic field. Therefore, we can see more iron filings sticking at the poles. As the lines spread out, the magnetic field weakens.
Why did I come here?
That was the best time of my life.
You had an amazing experience.
Yes, I miss my friend.
Okay. So magnetic field is the region around the So, sa video, understandable naman itong sa itong magnetic field. Magnetic field is the region around the magnetic material or a moving electric charge within which the force of magnetism acts. Mao to atong naitabo sa katong mga iron filings na kuan siya sa katong magnet, katong na alien, mao to siyang magnet na naay north pole of south pole. Okay, ayun ko lang sa please po next slide na.
One.
Hello, hello, madungog ko?
Okay ka na.
Okay. Ipaliw ko balik atong kuan. So, ang SI unit diay sa magnetic field kay Tesla. T. After the eccentric but brilliant inventor, Nikola Tesla. So, next. Paliw ko next. So, magnetic field lines are imaginary lines that represent the direction of the magnetic field as we move from one pole to the other. So, kaning naay kanang murag linya-linya nga nikuan katong gilinyahan sa katong mga iron filings kay tawag ato niya magnetic lines. So, next. So, mao din yang balik. So, properties of magnetic field lines. So, magnetic lines, of course, never intersects. So, di siya mo mag-abot kay one way raman siya, like from North Pole to South Pole, then inside kaya to siya sa South Pole to North Pole. Yung ano rayaha. So, mura siya magtuyok-tuyok lang. So, di na sila magka-abot. So, next is by convention, magnetic lines point, magnetic line points from north to south outside a magnet and from south to north inside a magnet. So, di ba mag-start ang kanang kuan diri man sa North Pole no. Ikaw na niya mo adto na siya padung sa south, sa gawas na siya magnet, sa magnet gawas sa magnet. So, maguna siya sa north, then moadto siya sa south, then igabot niya dito sa south, musulod na siya dito sa sulod sa magnet. So, ari na po siya magsugod sa south kaya syempre di ka doon siya sa north south, so ikabot niya sa south dito na din siya padung sa north. So ano rin siya tuyok plus siya dayon field lines converge where the magnetic force is strong and spread out where it's weak. So kato bitong kabantay mo kanang kilid sa north ug sa south, di kanang kilid jud sa magnet, kabantay mo katong sa video kay daghan siya og iron filings kay minsan na dito nga part kay kusog iyahang magnetic force dito kay dito madaghan man itapok dito nga katong murag katong iron chuchu. So sa kuan katong mga layo na nga dapit bitaw like kanang nay nakabutang dira magnetic field strength dira nga dapit kay dira na siya muhinay-hinay na ang iyahang kanang kuan magnetic force kay nalayo-layo na siya sa kuan. Yeah, so next please. Mao ni siya ang kanang mga under sa magnetic field or mga example na makita na to diri ang kanang mga singanang direction sa magnetic fields. Diri una kaning unlike poles at track, makita na to ang mga ang direction sa kuansa. So di ba ang magnets kay opposite attract man siya no. So south ug north. So attract ka kanang magka-sikit man ano kabantay mo tong magnet nga itom nga duwa-duaan gina nato sa unar ako ra guro. If yana na to kay di siya masumpot if pareha siya og kuan like pangita north di siya masumpot. So kani kay na-attract siya kay kuan man south ug north man. So mo na iyang kanang line niya magnetic line kimo na ni dito siya dito na siya sa south. Human arita sa next sa bar magnet na makita ra siya no sa bar magnet mawala na siya katong ganiha nga porma tong nasa video mawala to siya nga porma sa katong magnetic lines. So ay sa like pulse repel awa tanawa ninyo same siya north of north so dili jud siya magkasikit. So mo na lahi iyahang dagan saya so lahi ang padulungan sa iyahang magnetic line kay dili man sila magkasumpay kay parehas man sila og kuan. So diri kay katong sa limot ko unsa na siya. Dayon naman nari sa next kay sa earth magnetic field ni siya. Wait. Kaning next kay earth magnetic field ni siya. So na north ug south pole Japan. Mora Japan iyang dagan more magsugod sa north then ato sa south. Diri sa next na sad kay katong current wire katong long straight siya kanang usara bitaw kana magbitbit pag wire bitaw. Then ginita nimo dira mao na siya ang dagan sayang kung magbutang ka dito magnet iyang dagan sayang magnetic line kay mura patuyok bitaw. So sunod kay kaning sa ubos pare-parehas ra gyud na siya. Okay, next please to next. So kaning nga rule is kanang useful ni siya sa kanang pagkuha sa magnetic field kay makadetermine man siya sa direction sa magnetic force sa kanang convention current ug sa magnetic field morning needed niya ang right hand rule. So naay tulo ka right hand rule but duha akong gikuan kay since magamit mo siya sa problem later so kanila ko nahon. So una is the right hand rule number 1 determines the direction of magnetic force, conventional current, and the magnetic field. So given any two of this, the third can be found. Atong sige, ipakita. Muna siya ang forma sa rule number 1. Using your right hand, point your index finger in the direction of the charge velocity. So, recall conventional current na makita na dira ang sayang kuan. So, point your middle finger in the direction of the magnetic field. Point your middle finger in the direction of the magnetic field. Sumo na ang B. Yeah, murag nag-anak bitaw yang forma like something ana. So, your thumb now points in the direction of the magnetic force. Sumo na siya. The next rule kay ang number 2. So determines the direction of the magnetic field around a current carrying wire and vice versa. Kani nga rule kay mao ra ni siya katong sakuan. Diri gamit kani nga rule kay kanang kita nimo ang direction sa magnetic field if magkupot ka sa usa ka wire. Like pareto katong ganiha nga kuan. So using your right hand, curl your fingers into a half circle around the wire. They point in the direction of the magnetic field B. So point your thumb in the direction of the conventional current. So ato sa top kay murag mahog siguro nga positive dito. So yeah, next. So diri ka na, di ba dagan man tog under sa magnetic field no? Patakong gipakita ganiha. Pero akong i-show lang diri duha lang, tas maghatag ko problem. So kani force on moving charge in a magnetic field. So the magnetic force on a moving charge is one of the most fundamental known. Magnetic force is as important as the electrostatic or Coulomb force. Yet the magnetic force is more complex in both the number of factors that affect it and in its direction than the relatively simple Coulomb force. So the magnitude of the magnetic force, so ang kanang F, tawagan niya is magnetic force. So ang kanang Q is the charge. Dayon ang V is the velocity. Dayon ang B nga kanang dako nga B is the magnetic field of strength. Dayon, sine theta. Yan next. So where theta is the angle between the direction of V and B. So makita na dito kanang angle if na-figure dito, makita ra dito ang kanang angle gikan sa V ug sa B. So this force is often called the Lorentz force. So sa din ang Lorentz force is the Lorentz. So the force exerted on a charged particle moving with velocity through electric field and magnetic field. So mo na siya ang kuan. Hindi lang mo kuan na kamurag apil na sa sunod. The next please. So, there ang problem. Example problem ato nga kuan. So, a proton moves at 8 times 10 to the power of 6 along the x-axis is the entire region in which there is a magnetic field of magnitude 2.50 Tesla. So, directed at an angle of 60 degrees, which the x-axis and lying in the xy plane. So, now, makita dito sa figure. Ana. So, ang V, so na V-axis no? Okay, so ang una na ito pangitaon kay ang initial magnitude and direction of the magnetic force sa proton. Tayo next, atong i-calculate ang proton's initial acceleration. So next, naman siya ang solution. So find the magnitude and direction of the magnetic force of the proton. So ato gamiton ang formula nga magnitude of the force. Kaya makita man ta sa magnitude mo. So, now na to. Gamit ani nga formula. So, dayon, naman to yung mga given dito. Katong velocity, katong na Tesla, kaning Tesla, katong magnetic field strength, dayon na ay angle dito. Nakita mo to sa figure ganina. So, ang kaning Q, kaning charge, is kuha ni siya kanang column ba to? Charge ni siya sa proton. Kan di ba proton man atong tuyuan ni mga problem. So kanang 1.60 ang minahan na kay ang charge sa usa ka proton kay equal siya sa 1.60 times 10 to the power of negative 19 nga kanang kuan. Sige na column sa mao na siya ba makita na siya sa kuan. More given na siya daan ba? Dayon, i-times na nimo silang tanan, kunya, ang result kay mao na, nakuha na nato ang magnitude. Kanang F. So na nato F. So ang next na to paon kay ang direction sa magnetic force. Asa siya paingon. So gamito na to tong rule, katong number 1 rule na naman dito. Apply right hand rule number 1 to find the initial direction of the magnetic force. Ano to gamiton? So, nanagiri point the fingers of the right hand, the x direction, the direction of V, velocity. And then curl them toward the B. So, mawala to siya katong nakita ganyan sa kuan. So, the thumb points upward in the positive Z direction. So, ang tab, ato pa doon katong Z direction. Katong kita mo itong figure sa babaw. Z direction to siya kay. Wala naman siya masud sa XY nga plane. Ang nasud kay katong mang B o B. Sunod, atong i-calculate ang proton's initial acceleration. So, para makalculate na to ang initial acceleration, mo gamit ta og Newton's law, and Newton's second law. So, katong force equals mass times acceleration, mo gamit ta ato. So, since naman tay mass o kanang force, katong F, ganyan atong nakuha, so, atong pangitaon kay ang acceleration. So, ito'y may tabo. Di ba ang formula is F equals ma. So, may tabo na imo siya ka nang ibalhin. So, may mahimo na siyang A, acceleration, equals force over mass. So, mo na, substitute na to dito sa babaw, sa force, i-substitute na to ang 2.77 times 10 to the power of negative 12 Newton. Dayon sa obus, i-substitute na to dito ang mass. Mass na katong given na daan. Dayon naman, makuha na natin dayon ang acceleration. So next, ganun na, alam mo ko nga, pili ko, ay naiduha nga, example lang na kuha na ko sa magnetic field. Daghan man to sa ang kaduha kay kani magnetic field ko long straight wire. So the magnitude of the field at a distance r from a wire carrying a current I is given by the formula above where mao na siya. Is called by permeability of free space. Tumawa na siya ang formula nga gamito nato sa kuan. Katong ni siya ang current wire nga katong ganiha katong magunit tag usa ka wire. Then dira nato panon ay palig ko sa next. Kani diri sa example. Kani siya nga example kay ma-relate jud siya atong current wire man siya. So naay katong mura katong ganiha bitaw nga pakita na ko nga picture katong naay wire nga gunitan ra dito. So mao ni ang problem. So ang vertical wire carries a current of 45A due south. So padung south iyang kuan. So calculate the magnitude and the direction of the magnetic field 2 cm to the right of the wire. So next. Ang solusyon ani kay di ba kanang kilid nga drawing kaning naay murag kuan wire na siya kanang murag ana wire I mean dili siya wire kanang tawag mura siya kanang tingnan na like basta makapilit dito ang kanang magnet mopilit dito ang magnet ba like maghunitaan na din butangan na to kanang kuan kanang iron filling sumutuyok siya dito makita dayon nato unsa asa padung iyahang kanang magnetic field line tumagtuyok siya so ato gamiton nga formula katong ganiha itong B equals kuan so i-substitute ra nato dito so since given naman ang kuan ang kaning babaw mo nga constant raguro siya given na siya i-substitute ra nimo dito then ang kaning 45A given na siya sa problem due south so i-times nimo sila then divide over 2 pi then naman ang kaning 2 cm i-kuan siya i-convert siya sa meter naman na i-times nimo dira ang 2 pi o kuan then i-calculate nimo then kuan na dayon ang result next. Okay, that's all guys. So, balik, next reporter is mabalik si Kuan ko nag-break po. Thank you.
Thank you, Vanessa. So, the next topic is the magnetic induction. So, this magnetic induction means if a natural magnet has brought near magnetic substances such as iron, nickel, cobalt, etc., it induced magnetic properties in them. These properties is called magnetic induction. So, ang kaniyang pasabot is kaning magnetic induction used to make artificial magnets. So, ang katong mga substances na dili magnet is pwede nimo siya magnetize or mabalhin ang iyang kuan na makuan siya magnet as temporary or artificial magnet. So before that we will show you a video about the magnetic induction. So Eliza, please play lang.
Such as iron, nickel, cobalt, etc. It induces magnetic properties in them. This property is called magnetic induction. Magnetic induction is used to make artificial magnets. There are several methods which can be used to make artificial magnets. The first method is single touch method. In this method, the steel bar to be magnetized is placed on the table. The bar magnet is then taken and one of its poles is placed on one end of the steel bar. Stroke the steel bar with a bar magnet from one end, that is A, to the other end, that is B. Keep the magnet inclined. When the magnet reaches at position B, lift it and place it again with position A. Repeat the process several times. The upper side of the steel bar gets magnetized. Now, turn the steel bar upside down and stroke its lower side with the bar magnet several times until it gets magnetized. Point A, or the starting point of the steel bar, will get the same polarity as the pole of the magnet touching it. Point B, or its other end, gets the polarity opposite to the magnetizing pole. The second method is double touch method. Place the steel bar to be magnetized on the table. Place two strong magnets in the center of the steel bar in such a way that the opposite poles are close to one another. Stroke the steel bar with the magnets. That is, move the magnets to the opposite ends, keeping them inclined. Repeat the process several times until the steel bar gets magnetized. Point A, where the north pole touches the steel bar, becomes the south pole, and the other end of the steel bar, or point B, becomes the north pole, as the south pole of the magnet touches it. The magnetic properties of artificial magnets made by the single touch method and double touch method can be tested. Place some iron nails on the table. Bring the magnetized steel bar near the iron nails. The steel bar attracts the nails, indicating that the steel bar is with the induced magnetism. The third method is the electrical method. In this method, an insulated copper wire is wound on a steel rod to be magnetized. The three ends of the copper wire are connected to the battery. To construct a battery, a number of dry cells are connected in series, with the positive terminal connected to the negative terminal of the adjacent dry cells. Allow the current to flow for some time. The steel bar gets magnetized. The polarity of the rod depends on the direction of the current. If the rod is viewed from point A and the current is flowing in a clockwise direction, then the point attains the south polarity. If the current appears to be flowing in an anti-clockwise direction, then that end attains the north polarity. The steel bar does not lose its magnetism easily. Rather, it retains the magnetism for a long time. Its protectivity is high. Thus, it becomes a permanent magnet. Thus, the electrical method is more suitable to make high-strength or powerful magnets. The magnets hanging on the refrigerator door, holding up an artwork or photos are examples of permanent magnets. If the bar is a soft iron bar, then when it becomes a strong bar magnet, it is called electromagnet. But as soon as the current is stopped, this magnet ceases its magnetism. Let us learn how to make an electromagnet. Take a soft iron bar of a required shape. Wind an insulated copper wire on it and connect the ends of the wire to a battery along with the switch. The switch is used to make or break the circuit. If the current is switched on or allowed to pass through the copper wire, then the iron bar becomes a high-strength or powerful magnet. If the current is switched off, it loses its magnetism immediately. Thus, an electromagnet is the one which gets magnetized when the current is passed through the surrounding coil and loses its magnetism when the current is switched off. Electromagnets have many industrial applications. They are used to lift cars and other materials in scrap yards. They are also used in electric bells. The fourth method, which is used to make artificial magnets, is the induction method. An iron bar or a steel bar is placed near a strong magnet and it gets magnetized. The end of the bar near the south pole of the magnet becomes the north pole, and the other end becomes the south pole. A magnet attracts an iron body only due to induction. The region of the iron body over which a magnet has its influence and attracts the iron body is called magnetic field. Magnet is always surrounded by a magnetic field. Hence, when an iron body is placed in this field, magnetic induction takes place, and thus the iron body gets magnetized. A magnet is surrounded by a magnetic field, which is made of magnetic lines of force or magnetic flux. To prove this, let's carry out an activity. Place a drawing board over a magnet and fix the white paper on it. Sprinkle some iron fillings on the white paper. Tap the paper gently. The iron fillings will arrange themselves in definite patterns. These definite patterns, or curved parts, made by iron fillings, indicate the magnetic lines of force. A magnet loses its magnetism by vibrations or rough treatment, such as hammering, dropping, etc., particularly when it is lying in the east-west direction. A magnet loses its magnetism when it is heated to redness and then allowed to cool while it is lying in the east-west direction. The process used for destroying the magnetism of a permanent magnet is called demagnetization. To conclude, magnetic induction is a property which allows us to make artificial magnets which are of great use.
Stop na, Eliza.
Why?
Okay, so as you can see from the video, so there are different ways how to kanang make an artificial magnet. So it's a magnetic induction. So one of them are the magnetic methods is used to make artificial magnets. An iron bar or steel bar placed near a strong magnet and it gets magnetized, and the end of the bar near to the south pole of the magnets become the north pole, and the other end becomes the south pole. So tinyo nakita is so na po siya connected sa magnetic field katong mga lines niya. If kusog gani siya, mas kusog mupuan ang mo magnetize ang katong steel bar. So ang katong ang opposite direction, ang katong iyang south pole kay pag mag-magnetize mas himo na siyang north pole, then ang katong ang north pole mahimo na siyang south pole. So other example are katong duha is the single o katong double touch method. So Eliza, next. So first is the magnetic induction, a single touch method. So this method is to magnetize a steel bar. A bar magnet is then taken, and one of its poles is placed on one end of the steel bar. So stroke the steel bar with the bar magnet from the one end to another end. So repeat the process several times. The upper side of the steel gets magnetized. Repeat it from the back of the steel bar and get magnetized both sides. So, ang kanin siyang single touch method is katong nakita niyo sa video is katong murag ang katong steel bar is yang gikuan from this side to paringalit sa side na po. So, ang katong gikuan is which is the north pole ang iyang gikuan ato grab ato sa steel bar. So sige mo grab ato kay magnetize to siya, then ang katong first side is become north pole, then ang sa last is become a south pole. So both side you should kanang magnetize. So katong nakita niyo sa video is katong steel bar is pagkuha niya sa mga nails kay nang dikit ang nails ato sa steel bar. So ang katong steel bar is get magnetized. So the next method is the double touch method. So so next, Eliza. So double touch method, placed in the steel bar and used to strong magnets in the center of the steel bar in such way that their opposite poles are close to one another. So magnets. So move the magnets to the opposite ends, keeping them inclined. Repeat the process several times until the steel bar gets magnetized. So point A, with north pole touches the steel bar becomes a south pole. So the other end of the steel bar of point B becomes the north pole as the south pole of the magnet. So ang steel bar is duha ka bukang nagkuha ng magnet. So ang usa nagigamit sa point A is ang tumoy sa north pole sa magnet, then ang usa sa B ang gigamit na point is south pole. So sa katong pagkuha nimo mamagnetize siya ang ang north pole na tumoy sa magnet becomes a south pole niya. Ang katong south pole nimo nagigamit na end becomes a north pole. So both sides gihapon imong i-magnetize para mas makuha po siya ato same ato sa single touch method na mo-attract ang mga ang steel siya apod na wala po siya magnet. So it's temporary artificial magnets lang siya. So to lose the magnetic or ang iyang yung pagka-magnet is nato sa mga examples sa last is katong pag dukdok sunugon siya will lose the magnetic. So dapat dito example sa electromagnetism. So di namin mo pa nato further kay kato siya kay topic siya sa next group. So hope nakaantisabot ra mo ato. So the magnet so summary sa magnetic induction is to make a artificial magnets. So that's all, guys. Liza?
Excuse me, may I know the full name of the last presenter just a while ago? Rico.
Rico Conag, Miss.
Rico is your family name or first name?
First name Rico, Miss. Conag is last name.
Okay, thank you. So, do we still have another presenter for this group, or we will proceed to the next group?
Next group na, Miss.
Okay, thank you. When you introduce yourself, palihog ko iuna ang inyong surname. Palihog lang. Thank you.
Hi, good morning everyone. We are the 7th group and we will be discussing about electromagnetism. The subtopics include electromagnetic